the for loop is one of the most useful and common pieces of code out there. And it's often used with arrays, which is a subject that's a bit beyond the scope of basic programming here, but one you'll want to become familiar with. And the syntax can be seen here. Now, at first, the for loop can be confusing and intimidating. But after a while, you'll become good friends. An example from the Arduino website is shown here. And for clarity, I've removed the setup and loop functions, but just know that, of course, the setup and loop functions are required for every sketch. And let's take a closer look at the for loop. We have the word for, and then inside the parentheses, we have three different statements. First, we set or initialize the variable I to 0. And this only happens once the first time we go through the for loop. After the first time, this statement is ignored, and the other two statements are executed. So after we initialize I, we have a comparison or condition. So here it says I is less than or equal to 255. So as long as I is less than or equal to 255, we run through the loop, and here we already set I to 0. So before we go on, we jump right into the loop, and we execute that code and write the value of I to PWM pin. Then, once that value is written and we have the 10 millisecond delay, we jump back in and we increment I, and we see I++, that increments I by 1. Now, note that you don't have to use the name I. You could call that integer anything you want. You can call it temperature, you can call it mom, you can call it whatever. But oftentimes you'll see for for loops the letter I. But you don't have to use that letter. So we incremented I by 1. We go back to the for loop. We skip the first statement. We've already initialized it, so we don't want to reinitialize it to 0, or we never ever get out of the loop. So I is still less than or equal to 255. We jump back in, do the code, analog, write, and delay, and then increment I to 2, and so forth, until it's 255. Once it's greater than 255, we fall out of the for loop, and the code inside the loop ceases to execute. Now, the while loop is another gem you'll often find yourself using. It will loop continuously and forever until the expression inside the parentheses becomes false. And we can see the syntax here. It's real simple. We just have the word while, and then some condition inside the parentheses, and then we have, again, the curly brackets with the code in between. Now, note that the condition is a Boolean expression, and it's either true or false. The condition can be many things, like some sort of less than or equal comparison. We could throw the number 1 in there, which means true, and putting a 1 in there will make the while loop run forever, by the way. And we could even insert a function as our condition. For example, we can do something like this. In this case, the loop will run as long as analog read returns some sort of value that's not 0. And here's another partial example taken from the Arduino website again. Now notice that the ++ operator has reared its head again and increments the variable var every time we go through the while loop to keep count. So first we initialize an integer var to 0. Then we jump into the loop and we make the comparison. 0 is less than 200. So we go in and we do something, and then we increment var by 1. So now var is 1. And again, 1 is still less than 200, so we go back into the loop, and once it reaches 200, we fall out of the loop. That about wraps up our intro to control structures now. There are other control structures in the land of Arduino. However, I wanted to cover the ones you'll see the most.